Hello and welcome to my project demo. This project demo will go over the closest pair of points problem, which is that given endpoints in a Euclidean plane, find a pair of points that are closest to each other. We look over two algorithms for this project, the brute force algorithm and the divide and conquer algorithm. Pseudocode is here. The runtime analysis is this sentence here and this paragraph here. I make my code here, like generate array. In it, you can see where I have adding a random integer from 0 to 100, and it just keeps going until it generates the appropriate array. Oops. Here you can see the brute force closest points, closest points code. You can see how it has a nested for loop. It does the calculations as described in the pseudocode. It does the distance calculation, and it eventually returns the minimum. It also uses generate array, which is the random array thing, to test it. I make a small test case of 5 points, and it just gives you the closest points. These are 0 index, so this would be the 0th point. This is the 3rd point. These two are the closest compared to everything else. After the brute force algorithm, we have the divide and conquer algorithm. This one is a recursive function, which also uses heap sort to construct part of it. As such, I made some heap sort code here, and I tested it with a small array. You can see how it changes randomly every time, and for the x coordinate, it sorts it in increasing order of x. For the y coordinate, it sorts it in increasing order of y. And you can see that I just pass in a parameter to make that happen. Then we have the actual code for the divide and conquer algorithm, about the calling function and the recursive part. And then it's called, and I put an alias so it's easier to read it. Again, with some test points that were generated earlier, you can see that we've got some indexes here, and we've got the 2 points themselves here. I have them separate so it's easier to read. I won't be running this one, but in here I show the average running time, or rather I calculate it. You can see here that it follows the pseudocode given in the assignment, where I do for n from the start to the end in steps of whatever. So with 10 iterations here, I start from 1000 to 5500 in steps of 500. I chose these values so that my code wouldn't take like hours to run. Instead, it takes minutes. We don't have that much time in the video though, so I won't be running this. You can see here that I generate the array, and then I use that same array in both brute force and divide and conquer here and here. I calculate each tuple of iteration, size, and then time taken here using the default timer and time it. And I write down the average of each of these over there. I'll just scroll through here to show it. I print out the average alg1 and alg2 right here and here, and they have the averages along with the sizes associated with each. You can see how there's 1000 up to 5500 and how the time goes up. This first one is the brute force, the second one is divide and conquer. I then show I then construct the tables. I calculate C here, and then I change it into predicted RT, then I drop C because we don't need it anymore. I do the same thing for both tables, of course. And then I also plot them out. Here's the empirical RT. You can see it goes up, and this is pretty much shallow. It roughly matches the predicted value here and here, but it never exceeds it. And my conclusion is that everything worked as expected. And that's everything. Hope this video was helpful. Bye.